Yes, Professor.
Okay. Let's go through this and then we'll have a quick quiz. Okay, so we just finished the histograms. Let's talk about cumulative distribution. So they say that this is a variation of the frequency distribution that we saw earlier. Let's quickly review that. So we had frequency distribution for a categorical, but also for a quantitative variable. So remember, we had this quantitative data. We broke it up into intervals with a class width. And we had this result. And we also had a result like this, where we had it in percentage, or like this, and like this. So now with that in mind, let's go back here. So it's a kind of like a frequency distribution, but it's so-called cumulative. So it's not complicated. Taking the same data we had, let me bring that back again. So here's the original one, and here's the new one. So we can say how many audit times were there that were less than 14 days. Audit time is less than 14 days. So there were 4, because the smallest audit time was somewhere between 10 and 14. I don't remember which it was, but it's somewhere between 10 and 14. And so the number that are less than or equal to 14 is 4. Then we can say, well, how many are less than or equal to 19? So we know that between 15 and 19 there were 8. And then if we're talking about less than 19, we also have to include the ones that are in here. So that's 8 plus 4. So that's where this 12 comes from. And then if we ask how many are less than 24, well, the ones that are less than 24 are the ones that are in here, plus the ones that are in here, plus the ones that are in here. So that's 5 plus 4 plus, 5 plus 8 plus 4. So that's 17. Okay, and then less than 29, we can do this. Well, less than 29, that's the ones that are in here. That's the 2, plus these, plus these, plus these. So it's 17 plus 2 is 19. So this is what we mean by the cumulative frequency. So that's where these numbers come from. And then, of course, where do these numbers come from? You just take this and divide by the total number of elements, which I think was 20. And so you get this, divide this one by 20, this one by 20, this one by 20, and of course the last one, well, let's just focus on the last one for a minute. How many are less than or equal to 34? That was included the largest interval, so that's everything is going to be less than or equal to 34, so that's going to have all 20. So when you take this one divided by 20, it's 20 divided by 20, you get 1. So now, what does the graph of the cumulative look like? Well, it has to be increasing. It can never drop. You can never have a smaller number here than you have a number here. You can never have a smaller number here than you have here. It can't get smaller. It can only stay the same or get bigger. So the graph is going to be increasing. This is also still going to be increasing, but it's just going to be a percentage, or this is also, I guess we call it a percentage. So if we graph it, okay, they don't have the graphs yet, but let's look at it. Maybe the next one will have the graph. Not yet. Okay, can we get a graph? Okay, there isn't one there, but let's look at it here. So how many were less than 14? That was, how many were less than or equal to 14? 4. How many were less than or equal to 19, 12, 17, 19, 20? So that's what I have here. Less than or equal to 14, less than or equal to 19, less than or equal to 24, 4, 12, 17, 19, 20. So let's just graph it. Of course, you can see that it's increasing, but let's just graph it. Let's use the recommended charts. So you can see that it's increasing, or you can graph it this way and also see that it's increasing. So let's try this one first. So you can see that it can never be decreasing. So this is how many are less than or equal to 14. There are 4. How many are less than or equal to 19? There were 12. 24, less than or equal to 24, it was 17, and so on. So it can never drop down. And then, by the way, if you want to do the other graph, we go to Insert, and back to here. You can do this. So what's the difference here? It's just we draw a straight line from where's the other one? From the peak of the first bar to the peak of the second bar to the peak of the third bar, straight line from here to here, the peak of the next bar, and then the next bar was over here, and we draw that. So we get this. Again, it's not going to be decreasing. Okay, then the last thing in 2.2 is the stem. Okay, let's try this out. So let's go to Manaba and go to our class. And go to the test section. And let's do a group first. Don't forget to introduce yourself. Okay, does anybody have any questions about that? Okay, so let's try the individual questions. Okay, so try this one. Okay, 15 seconds to enter your answer. Okay. Okay, so what about this one? What's the answer to this one?
110.
Yeah, this number here, 110, because it's saying what is the cumulative frequency for less than or equal to 50? So less than or equal to 50 means all of these occurrences are less than or equal to 50. So are these, and so are these. So we just add up. There's 30 plus 40 plus 30 more is, 30 plus 10 is 40, plus 30 more is 70, plus 40 is 110. Okay, any questions? Okay, let's keep going. Leaf display. So let's take a look at that. I noticed actually that we have these data files, so why don't I work with that? So I'll just download this and open that. So here's the data. Now let's go back and check what this was again. So I need to go to here. And this was the number of questions answered correctly on an aptitude test. So here's one person, they answered 112 questions correctly. Here's another person, they answered 72 and 69 and so on. Okay, and this is the entire data set. So let's take a look at that here. So this is the entire data set. So there was one person that was 112, another person that was 73, and so on. So for the next graph that we're going to make, we're going to make another type of graph now. So we've talked about frequencies and cumulative frequencies and dot plots and so on. We talked about various kinds of graphs. There's one more here called a stem and leaf display, or a stem and leaf plot. So let's try and make that. So the way that we're going to do that here is first we're going to sort these. So let's sort them. So you can go to Data and Sort. And you can say Sort by Correct and smallest to largest. And you want to click this. My data has headers. Otherwise, it's going to include this as one of the data points, but we don't want to include that. That's just the label. So we say my data has headers or labels. So, okay, now we sort it. So we get that. So we have the same data, but it's been sorted. So there's 50 pieces of data because the first row is the header. So there's 50 pieces of data here. Okay, so now what we can do is we see that the smallest data is in the 60s and the largest data is in 140s. So we could do something like this, or this is the way we would do this. So we could do 60, 70, 80. So let's do that. And let's copy this down until we get to 140. Okay, so we have that. And now we can take each of the pieces of data in the 60. How do we do this? Okay, now we can take each piece of data that's in the 60s and copy it. And then, let me just start it here. I'm going to click here and I'm going to paste it, but you can do something called paste the transpose. So instead of it being copied to this cell and this cell, it's going to be copied in this cell and this cell. So let me do that. So I'm going to paste it, but there's something called this one here, paste the transpose, so we get that. Okay, now I can take the 70s and do the same kind of thing, copy it, start here and paste the transpose, so it goes like that. And then I can take the 80s, do the same thing, copy, paste the transpose, like that, 90s, copy, transpose, like that. Okay, I finished it. So you can see what I did, and you can see the result. Now this is kind of interesting because it's kind of like it's kind of turned sideways, but it's really like a plot. If you don't know what I mean, I could, let's see, I could copy it. Let's see, do that, copy it, and put it on this sheet, but I don't know how to do this actually. Let's see, if I transpose it, what's going to happen? So I'm going to paste and transpose. See what happens. Okay, well, I wanted it to be the reverse. I wanted it to be up. So just to achieve that effect, I'm going to copy it again to another sheet, and I'm going to paste it as an image, which I think, oh, I can't do that. Can't paste as an image, so that doesn't work. Okay, maybe I can do this. It's taking a long time, but let me take a copy, screenshot, and do this, and copy it, and put it on another sheet, and paste it, and I wonder if I can rotate this. Yes, I can rotate it. Okay, so it doesn't look that great, but it's kind of like a histogram now. You can sort of, actually it goes from 60, it goes in the wrong direction. I don't know how I can fix that. But anyway, the point is you can sort of see the distribution here. So you could ask, is it skewed to the right? Is it skewed to the left? Is it symmetric? What does it look like? Now this is all backwards because these numbers are in the wrong direction, but we could go to here and you can see that it's like a histogram, but it's on its side. Okay, so I guess I would say it's fairly symmetric, more or less symmetric. It's not exact, but I would say that it's close to symmetric. Okay, so this is the basic idea of a stem and leaf plot. So these are called the stems here. Usually we put them next to this. So these would be called the stems, and these are the leaves. Now, let's look at, it doesn't look quite like this, like we don't usually have, well, actually we usually do, I think. Anyway, let's look at this in the text. Okay, so let's look at how they show the stem and leaf. So they said they have 150 question aptitude test given to 50 people. So we have 50 pieces of data in here, and then this is how many answers each person got correct. Okay, let's have a quick quiz now, group quiz. So let me do that. So introduce yourselves if you haven't already, and make sure that you can do the problem. Okay, go ahead and try the quiz, the individual quiz. Okay, 15 seconds. Okay. Okay, these were reviewed. Does anybody have a question about these? Okay. Let's say that, let's just, nobody has any question about this? Is this clear? Everybody remembers this?
Professor, can you just go through it like quickly?
Okay, let me go through it.
Please.
Okay, so this is one of my most important concepts. So, so that's why, even though you might think it's useless, you still have to learn it because you still have to learn it. So let's go through this concept again. So the question was, what? So here, here's the data set, and the question is, what are the elements for this data set? So does anybody have an answer? So what was this data? It says the number of questions answered correctly on some aptitude test. Okay, so that's what the data is. But the question here is, what are the elements of this data set? Remember that the word elements means we are measuring attributes of some element. So what are the elements here?
Is it the people who took the test?
Okay, somebody said the people. Anybody else want to offer another answer, or does everyone agree with that one?
I think
I know you love me.
The number of correctly answered questions on the test.
Okay. Okay.
I
think the test.
Okay, let's discuss it. So the idea is, this concept is that, so when we, okay, quiet, please. What is that? How do I do this? Let's see. You know. Okay. Okay, so the idea is, let's say we, in statistics, we often talk about something called a sample. We'll be talking about that. So we're going to start with a big what we call a population, and we're going to take a sample. So anyway, when we take a sample, there are elements in the population. We're going to take samples from the elements. Okay, so anyway, when we talk about the elements, we also, what's another word for element? in our class. We used another word also.
Individuals.
Right. Okay, everyone remember this? Element or individuals, right? So remember we talk about the elements or the individuals, maybe they're people, and then we can measure what? Their height, their weight, their income, monthly income, for example, and how many correct answers they got on some test. That's another possibility of what we could measure. Or we could say, we could measure favorite beer. Maybe they don't like beer at all, or they don't drink beer. Favorite cake. Maybe they don't like cake at all, but favorite cake. Okay, so we can measure all these things. So what are the variables? What are the variables here that I'm talking about? Right? These are the variables, their height, their weight, their income, and so on. Does everyone know what I'm talking about?
Yeah.
This is the element, though. This is the element. These are the variables based on that element. Now, it doesn't have to be a person. You know, if we were at APU and we looked at the ceiling, we would see these kinds of light bulbs. You know, they're kind of long, like that, right? This is a light bulb. And we could measure different things about that light bulb. For example, its cost. What else could we measure about the light bulb?
Lifetime.
What else?
Brightness.
Brightness. What else? Color. Is it working or not?
Brand.
What?
Can we measure the brand? Oh wait, no.
Oh, the brand, right? The brand. Okay, good. So in this case, what are the elements? What are the elements? The elements are the light bulbs. And each light bulb that I look at is going to have a cost, a lifetime, a brightness, a color, a brand, whether it's working or not, and so on. So these are the variables, and the elements are the different light bulbs. So I could look at 100 different light bulbs at APU. Maybe they have different costs, different lifetimes, and so on. So the variables for each element. Does everyone understand? The variable value for each element. Okay, so the elements are the things that you're measuring the variables about, right? So these are the elements. Could be people, they could be light bulbs, they could be anything. But then from the element, you measure different attributes or different variables. Okay, that's the concept about this question, regarding this question. So let's go back to it. So what's the answer? What are the elements here? Which answer is correct?
People.
The test.
The test?
The question in the test.
No.
The test.
No.
Then it's the people.
The number of questions answered.
It's the people.
Okay, I haven't been able to. I still haven't been able to convey this concept yet to you guys. I'm not sure why I can't do that. The answer is number 4. It's the people. The elements are the people, and then we're measuring, in this case, a particular attribute of each person? What attribute are we measuring of each person? Another word for attribute is variable, but the word attribute is more natural. So what attribute are we measuring for each element, or for each individual, for each person?
How many answers they
Answer.
got correct?
Number of
Right,
correct.
the number of correct answers. What else could we measure about these people? Anything else?
I mean, everything you can measure.
Everything, right? We could measure nearly
Yeah.
and all kinds of stuff, right? And kind of an infinite number of things, like their height, their weight, their number of hours they slept last night, the number of hours they slept the night before, their favorite food, their least favorite food, their favorite drink, their least favorite drink, their favorite television show, and so on, right? We could just go on forever and ever. Those are the different attributes, many different attributes for each individual. The individuals there are I guess the students or the people who took the test, right? And what are we measuring in this particular case, though? This particular data set, what are we measuring? So we already answered it, but what are we measuring?
Correct answer.
The number of correct answers, right? That's just one thing we could measure. We could measure many things about them, but that's what we're doing here. So the elements, though, are the people, and then what we're measuring is how many correct answers they got. So that's the variable that's being measured. So that one is which one? This one here, number 5. Okay, and then last one. With regard to this variable, is this variable, the number of correctly answered questions, is that nominal, ordinal, interval, or ratio?
Ordinal.
Interval.
Ratio.
Ordinal, interval, ordinal, interval, nominal, and ratio. Okay, we're going to get all the answers, but which one is the right one?
I think it's interval.
Okay, what's the difference between interval and ratio?
Interval has a unit.
Interval has what?
A unit, like Celsius, degrees.
What?
Like Celsius, degrees, this kind of unit.
Ah, Celsius. Right. That's right. Interval, Celsius is interval. That's right. So what about ratio? What's the difference between interval and ratio? Is there a ratio measurement for temperature? So he already gave Celsius, and that was an interval measurement. But I just said, is there a ratio measurement?
It's like 2 times of something or half of something.
Okay, somebody just gave me the answer that there was that Celsius or centigrade, Celsius. How do you spell Celsius? Celsius. I don't know. I can't even spell right now. I'll write it as centigrade. Okay, centigrade, he said, is interval. So I said, is there a temperature measurement which is ratio?
Kelvin.
And what's the difference between these two? Why is one interval and one is ratio? Ratio means you can talk about the ratios of two scores. So like you could say, the temperature is 270, or you could say, or let me make it easy, 300, and you could also say the temperature is 150, and you can say that 300 is 2 times as hot as 150, right? 2 times as hot. 2 times as hot, right? Remember this?
Yeah, but I thought we couldn't say that. I thought that temperature wasn't.
That is true. That is true for Kelvin. It's not true for centigrade. And why is that true for Kelvin and not for centigrade? Because we have what?
Absolute zero.
Right, we have absolute zero, right? So what? That means, what do I mean? I mean, what does absolute zero mean?
0 point.
Yeah. But right. But temperature, we can say measures what? Of course you can say measures heat, but I want a different answer.
It measures the movement velocity of molecules.
Okay. Yeah, it measures the movement, or we can just make it simple and say the energy. Measures the movement of the molecules or the energy of the molecules. So what does this mean? It means zero energy. It means they're not moving at all, zero. So if you have a zero, and if it measures, if it indicates the absence of the thing that you're measuring, that is ratio. So that's what we have here. For Kelvin, when we have absolute zero, that means zero energy. It literally means zero energy. But for centigrade, what does zero mean? What does zero mean for centigrade? Does it mean zero energy or zero heat?
No.
No. It's just, what does zero mean, by the way?
It means the freezing point of water.
Yeah, it's just an arbitrary, why didn't we talk about the freezing point of alcohol, or the freezing point of helium, or it's just arbitrary, the freezing point of water. It doesn't mean zero. It doesn't mean the lack of something. It's just a pointer to the freezing point of water. So it doesn't mean the lack of energy. Okay, so it's not ratio. You can't say that if it's 100 degrees centigrade, that it's twice as hot as if it's 50. It doesn't really make sense. You might say that, but you're not really correct in saying that. Okay, it's not really a great sentence to form, to say that it's twice as hot when it's 100 degrees centigrade as it is when it's 50. I mean, maybe, obviously people are going to understand what you mean, but it's really not a great sentence to say. Okay, so, all right, so that's the idea behind. So what was it? Ratio data. You have to have a zero that means the absence of whatever you're trying to measure. Okay, now let's go back to our question. And here, what about this? Is this ratio or interval? What does zero mean in this case? If you had a zero here somewhere, what does it mean?
0 questions answered correctly.
Right. Everyone agree with that?
Yeah.
What does zero mean? Zero means no questions
answered correctly.
Answered correctly, right? So you have a zero. 0 makes sense as 0, right? It means that you got none. It means, like centigrade, if you say it's 0, it doesn't mean you have none. It doesn't mean you have no energy, okay? But this 0 means you have none, no questions answered correctly, okay? So then you can talk about ratios. For example, if somebody got 120 and somebody else got 60, I can say that, let's call this person X and this person Y, I can say X did twice as good, twice as good as Y, right? So ratios make sense. Okay, so what's the answer to this question?
Ratio.
Yeah, it's ratio data. All right? Okay. So that's good. All right, let's go on to the next video. So to make the stem and leaf, so they actually don't say 60, 70, 80, 90. They say 6. So this is read as, there's the smallest element apparently was, let's see, 68. Well, 69 and 68. So going back to here, so what they do is they say, oh, well, we found a 69, so we'll put a 6 and a 9 there. Then I guess they said we found a 72, so we'll put a 7 and a 2 here. And they said, well, we found 112, so that would be 112. So that's typically the way it's written, not 60, 70, and so on. So this would be read, there was a 69 there. This would be read, there was a 72 there. So you keep doing that, but then sometimes you'll get more than one. So you get a 6, a 9, and an 8. So then you get this. Mine, I guess, was, I sorted it, so I had a 6, an 8, and then a 9. I guess this is also acceptable. I know, they do sort it finally at the end. So you get this kind of picture, which again is kind of like a histogram, but on its side. They pointed out that it's kind of like a histogram on its side like this. It sort of emphasizes that fact. We don't usually put those bars there, but to emphasize the fact that it's kind of a histogram. So they say, although the stem and leaf display may appear to offer the same information as a histogram, it has two primary advantages. The stem and leaf display is easier to construct by hand, I guess, and within a class interval, say 60 to 70, the stem and leaf display provides more information than the histogram because the stem and leaf shows the actual data. So if we just had a histogram, we wouldn't see that this one was composed of 68 and 69. We just say that there was a bar of there was a certain amount of data between 60 and 70. But here we can see exactly what data is between 60 and 70. And then they also point out that if you wanted to, you could split up some of them. So if, like here, we had kind of a lot in 70. So we might want to sort of spread it out. So we would go 70 to 75 and then 75 to 80. So they could do 70 to 70. I guess this is from 70 to less than 75. And this is 75 to less than 80. So you get 72, 73, 73, 75, 76, 76. And then 80, they also split up. So this is from 80 to less than 85. And this is from 85 to less than 90. Okay, so you could split it up like this as well. So they say, if we believe that our original stem and leaf display condensed the data too much, we can easily stretch out the display by using 2 or more stems for each leading digit, like this. Then they say, note that the values 72, 73, 73 have leaves in the 0 through 4 range and are shown in the first stem value. And the values 75, 76, 76, so these have leaves in the 5 through 9 range and are shown in the second stem. And here they point out that you could do, with larger numbers, you can still do this. So preceding example showed a stem and leaf display for data with as many as 3 digits. Stem and leaf displays for data with more than 3 digits are possible. For example, consider this, which is the number of hamburgers sold by a fast food restaurant for each of 15 weeks. So we have this data, and so I guess they're representing 15. Okay, so what does this 15/6 mean?
156.
It means this number here, right? 1565, right? So the leaf unit is 10. So this is 15 and then 60, actually. This is actually a 60 because the leaf unit is 10. So so when we go from 15 to 16, we're going from 15, what is it? 1500 to 1600? Yeah, right. So this is going from 1500 to 1600. And in the 1500s, we have 1560. We have a case of 1560, which is this one. Actually, it's 1565, but we only write it as 1560. Okay? And then here, what does this 4 stand for?
1640. I mean 40.
So 1640, where's 1640? This is a 1640. We ignore the last digit there. So this is a 1640, and there should be one more. Here, no. Where's the other one? 16, oh, sorry. There should also be a 1670, so that's here. Okay, does everyone get this? So you can do more digits this way. Okay, let's have a quiz. So, group quiz. Okay. Okay, does anybody have any questions about that one?
The cumulative frequency. Is it?
Yeah, it's basically the same thing as cumulative. I mean, more or less the same thing as cumulative. That's right. So, any questions? Yeah, the question was basically reading this, but then asking about cumulative. Okay, let's have an individual test quiz, rather. Okay, try that one. Okay, 15 seconds. Okay. So what's the answer here?
4.
Suppose we have the above stem and, I mean answer? No. Suppose we have the above stem and leaf. How many times is the pulse rate below? Yeah, that's right. The answer is 4. Below 70, that's the 60s. So there's a 68, 68, 68, and 69, so that's 4. Okay, any questions about that? Okay, let's keep going. So you could get one like this. Okay. Okay, so we covered various kinds of displays of the data. We talked about frequency distributions and cumulative frequency distributions and dot plot and now stem and leaf. Let's just quickly review. Okay, actually, they have down at the bottom. This actually, basically, they just say no. Okay, I'm going to skip this. Okay, let's take a look at Chapter 3, which is called Descriptive Statistics, Numerical Measures. So let's see what's in Chapter 3. So some of these are probably familiar to you. For example, the mean and maybe the median. We'll cover all of this. So let's take a look at that now. So these are all, in Chapter 1, they're all called measures of location. I prefer to call it measures of center, measures of the center of data. Okay, so the mean and the median, for example, they both measure the center of the data. But there's one in here in the list that called percentiles, and that's not a measure of the center. So they're calling all of them measure of location. So that's so the mean and the median we can call the measures of center, but if we're going to talk about the mean, median, and percentiles, then percentile is not a measure of the center, but they're all measures of what they call location. So let's see, for example. So for example, we have this data here. We might say, well, what's the mean of this data? And it's very obvious how to compute it. For example, suppose we have this data and you want to compute the mean. So let me just line this up in a different way. So remember, you can copy something like this and then you can paste it by doing what's called the transpose, this one here, and you get that. So we have these numbers, and we want to know what the mean is, and I think everybody knows how to do that, but I'll just write it here. I'm going to practice using this board that I have. Okay, I'm going to try this, but I'm really not very good at this. But so 5, so we just have to divide that. Okay, so what is the mean of that? So I think everybody can see that it's balanced right in between here. It goes 5, 6, 7, and 10, 11, 12. So what's the distance between 7 and 10?
3.
3, right? Of course it's 3. So if you go halfway, you're going 1.5 so up. So 1.5 from 7 is 8.5. So the mean, I think everybody can see, the mean is going to be 8.5. So first I made a mistake and I called it 9.5, but then I realized it was 8.5. Okay, anyway, so that's the mean, right? Is 8.5. Okay, and we use the symbol X bar to stand for the mean, or we can also use this symbol, which is a Greek letter mu. It kind of looks like a U, and it kind of looks like an M, and it's pronounced mu. Okay, and so if we had these numbers and we wanted to get their mean, of course, we would just add them up and divide by 4. I forgot the plus signs, but we would add them up and divide by 4, of course. And we would get apparently 8. And then if we could, okay, so let me just go to here. The first element of our data set as x1, so in this case here, the first one is x1 is 5. We'll denote the second element by x2. So in this case, the second element is 7. We'll denote the x3 will be 9, and x4 will be 11. So we could say that 11. So we could say that the mean is, instead of 5 plus 7 plus 9 plus 11, we could say it's x1 plus x2 plus x3 plus x4 over 4 in this case, because there are 4 elements. And if suppose we had 7 elements, then it would be x1 plus x2 plus, and we keep going up to x7, and then we would denote, then we would divide that by 7. That would be the mean. And suppose that we had, of course, if we had 10 elements, it would be x1 plus, how do I erase this? Let's see if I can do this. Okay, x1 plus, and we'd go all the way up to x10, and then of course we divide by 10. So if we want to be general about it, we'd say it would be x1 plus, we'd go all the way up to xn, and then of course we would just divide by n. So this is the general formula for x bar. Okay, let's also introduce or review another notation, which is called the sigma notation. And let me ask you, I think everybody might, maybe you don't know it, but you might know some Greek letters. For example, you might know you might know the Greek letter for A. You might know that it's alpha. You might know that the Greek letter for B is beta. I think this one is a small alpha, but this could be a capital beta. So just like in the Roman alphabet or the English alphabet, we have capital A and small a. They also have capital alpha and small alpha. I think the capital A might be this, just like that. Right? Maybe the capital beta is the same as the small beta, but just written in a bigger way. Do we know any other Greek letters? I think we know delta. We know the D, rather. We know D, the capital D at least, is delta. So we use that sometimes to rewrite like delta Y over delta X. Whoops, I don't know what happened there, but anyway, you know what I'm talking about. Okay, anybody know any other Greek letters?
Theta.
Okay, theta,
Alpha, delta, epsilon, omicron,
Epsilon.
omega,
omega,
iota, kappa, lambda.
Okay, somebody knows a lot of them.
I
don't
speak
know.
Greek, that's why.
You're Greek?
I'm Cypriot.
You're secret, but you speak Greek?
Yeah, it's a national language.
Oh, okay. Okay, great. What did you say, iota? How do you do iota? Like that?
Iota is in English I.
Yeah, but it doesn't
It's
look like this, right?
Yeah, that's iota.
Oh, that's iota, okay. All right, anyway, so except for her, does anybody else know any Greek letters?
No, that's it.
That's all. Okay, that's a lot. Well, actually, I know everybody knows at least one more. You know this one.
Pi.
Pi. And that's a Greek P, actually, I think. Is that right, Darnya? Is that right? Is pi a Greek P?
Yeah, pi.
Yeah, okay. It's a Greek P. So if I want to spell, let's see, P alpha, what's that? P alpha, whatever. So I guess this would be PAP. P alpha PAP P. I don't know. Anyway, that's a Greek P. This is a Greek A, and this is a Greek P. Okay. So so anyway, we know some Greek letters. Now, why do they use them in math? Well, okay, let's keep going. Talking about, and the English using a, which might be part of a sentence, you might use just like a sentence or something, distinguish them, so that anyway, we know some Greek letters. Now, it so happens that, you know, in mathematics, we use some Greek letters, and that's just to distinguish them, so that you don't sort of think that it's just like a sentence or something. So instead of using a, which might be part of a sentence, you might use alpha. Then you know it's not part of a sentence, it's some special symbol. So we sometimes use symbols like that. And I think you also know the Greek for S. Now, maybe you know it. What is the Greek S?
Sigma.
Yeah, I wanted somebody else, but anyway, yeah.
Okay, sorry.
That's okay. Sigma is a Greek S. There's a capital sigma like that, and there's a little sigma like that. So that's a Greek S. You might, well, everyone's probably seen this, and that is a Greek S. We call it sigma, but it's a Greek S. So if you wanted to spell let's say, I don't know what word begins with S. Anyway, you could write this, I guess, S-A-B. I don't know what stab. But anyway, this is an S, this is an A, and this is a B. Now, we know that S, or that sigma rather, because you probably know that we use it something like this. You might have some problem with this, but you probably know that we use it like this. And the reason that we use that Greek S is because it's for the word sum. Sum means another word for addition. So sum and addition basically are the same thing. And so for when we're doing addition, we use the Greek letter S because it's like the first letter of the word sum. Okay, so how do we actually use this? So for example, suppose I wrote, sometimes you might see it like this. Okay, let's try this out. So let's play with this sigma. Let's make sure everybody understands how to use it. So suppose I had sigma I plus 8, I equals 1, I equals 4. So what does this mean?
Something like from 1 to 4, like all of the data from 1 to 4.
Yeah, that's right. So what it means is you start out with I equals 1, you do something. Then you make I equals 2, you do something. I equals 3, you do something. I equals 4, you do something, and then you stop. So this says do it, for, 4 times basically, from I equals 1 to I equals 4. Now what are you supposed to do? What you do is you put whatever the I equals into here. So let's try that. So if I put I equals 1, I get 1 plus 8. Okay, then I do it with I equals 2. So I change this from 1 to 2, and I do that again, 2 plus 8. And then I do it again, 3 plus 8. And then I do it again, 4 plus 8. And then I stop. Does everyone get that so far?
Yes, Professor.
Yes.
And then, what does sigma mean again?
Sum.
It means sum, right? And why do we use the sigma for sum? Because sum starts with an S, and we want to use a Greek letter, so we're going to use the Greek S. Okay, does everyone get that?
Yes.
So that means that
Yes.
what we should put in front, in between here, is plus, plus, plus. So this equals this. That's what this means. This just means this. Okay, let's try another one. Suppose we have this. So what does that mean? So first we put I equals 1, so we get 1 squared. Then we put I equals 2, we get 2 squared. Then we put I equals 3, we get 3 squared. And then what do we put in between?
Plus.
Plus. So that's what this means. How about this one? How about this one? I equals, so if I'm lazy, I won't write the I here. So I might write that. In other words, I could write it like this. I equals 3, sorry. I equals 3, I equals 6. I could write it like that, or I could write it like I equals 3, 6, and leave out the I up here. Or you could be even more lazy and just write 3 and 6. Okay, so this means that, and this also means that, just being more and more lazy. Okay, so anyway, I have I equals 3, I equals 6. So what does this mean? So first I put in 3, so I get 5 times 3 squared. Then I put in 4, so I get 5 times 4 squared. Then I put in 6, so I get 5 times 6 squared. And then what do I put in between?
Plus. So
We get that. Now how about this? What do you think this means? Okay, well, I'll tell you. means you put in 3, you put in 4, you put in 5. So let's do that first. So put in 3, I get the same thing as before. 5, 3 squared. And then 5, 4 squared. And then, whoops, I missed something here. Sorry. 5 squared, right? Sorry about that. So then I get 5 times 5 squared. And I get 5 times 6 squared. But this is not a sigma, this is a pi. So what do you think this pi means? Sigma means sum. Pi means what? Any guesses?
Multiply.
Yeah, right. It's a Greek P. What's the word in English I'm talking about?
Product.
Right. So pi means product. Sigma means sum. So now I have a pi. So I'm not going to put plus here. I'm going to put what? Okay, so what about this one? What's that going to be? So first I put in I equals 1. Then I put in I equals 2. Then I put in I equals 3. And now what?
Multiply
Product
them.
sign.
Right. If it had been sigma, then what? Be 5 plus 1, 5 plus 2, 5 plus 3, and then what? Plus. Okay? Sorry, I forgot the 5 plus I here. Okay? Any questions about this?
No, Professor.
Okay. All right, let's have a quiz now. Okay. So let's stop. Okay, let's try another sigma with a different color. I put in I equals 1, so I get 5. It's going to be product. So instead of putting okay, so now we know what this means. Okay. Any questions about that? Okay. So next one is a individual one, but there's a slight mistake on it. So let me just show you the question first. Just clarify what it's supposed to be. Okay, can you guess what it's supposed to say? Can you guess what the question is? I made a slight error, right, in the notation.
Yeah.
I didn't give,
Professor.
yeah, I didn't give you the lower limit, right?
Yeah.
Yeah.
So it's supposed to be I equals 1 to 3. Okay, so let me turn that on, and then you can answer that one. Okay, so you can answer that one now. Okay, you have 20 seconds. Okay. Okay, what's the answer to this one?
18.
Because you put in I equals 1, you get 3 times 3. So the question was, I think this one, 3i should be I equals 1 to 3, right? So you put in I equals 1, you get 3 times 3. Plus you put in I equals 2, you get 3 times 2. Plus you put in I equals 3, you get 3 times 3. So that's, 3 times 1, 2, 3. So you get 3 plus 6 plus 9. That's 18.